So in that particular room, we control the environments. So that types of room, we can say this room is clean room. So clean room have very sensitive actually, because there is some airflow and other things is more important. Uh, if we use in clean room, we work with the clean room environment, so we take care of lot of things. So uh, before going in details, let me tell you why clean room is important and why we use clean room uh, for uh, for the fabrication of semiconductor devices, as well as some pharmaceutical medicines, and some biological uh, experiments we can perform in clean room. So we need uh, very clean environment, because we everybody knows the microorganism size is near about zero point 0.5 micron to 5 micron. These are the particles size, which responsible for the contamination of the product of semiconducting devices, or some biological or pharmaceutical materials. So for that materials, we need some clean room environment. So therefore we design the clean room for that product purpose. And other thing is more important in semiconductor devices, because nowadays we people working on nano electronics materials. So of course we working on nano level scaling. So we need some clean environment, otherwise what happen, so our devices getting some bad results. So we need for that device fabrication, clean room is required. Now next, what type of contamination is available in a normal environment? So everybody know the particles contamination is everywhere in air, like normal environment. So the contamination type is like organic dust, metallic, silicon dust, glass, or some wool, or some means dry clean hairs, makeup, or some cosmetic, bacteria, like that thing, oil, gas, fingerprints, like that. Lot of things in contamination at particular room environment. So these sometime we even we touch the device, there is also the contamination, like our hand have uh, some kind of ionic contamination, like sodium, potassium, calcium. If we touch, so this contamination, what happen, suppose this contamination is available in the room. This contamination affect the device properties or product quality. So what are the sources that from that sources this contamination available? So first is human being. So human being produce lot of contamination, like dry screen, oil, some fingerprints. Even we use some shoes, that shoes also making some contamination, uh, hairs, like that. So saliva, like that kind of contamination produce the human being. And some contamination produce the machines. Means suppose in your for example, in your lab have some vacuum pumps. That pumps produce some oil film, some mechanical movement in that pump. So in that case, some small uh, mechanical parts is come out from that pump, or like that thing. So many thing mechanical machines is available in lab, that machines also produce some contamination. So so like that contamination we reduce uh, in clean room environment. So suppose this contamination available in clean room, so what happen, suppose the mobile ions, like that sodium or potassium or calcium, like that charges, this thing is suppose this thing is available in device fabrication case. So that case some electrical field is produced, and due to that your device is sometime degrades or maybe dead, because the electric field is changed on silicon surface. So due to that, your device is dead, or maybe means if in suppose some cases is very sensitive, the potential difference is very sensitive case in device fabrication. So at that case, we should take care of that thing. Other is the impurity of silicon. Suppose some dust particle or some microorganism in clean room is available. So what happens when we fabricate some semiconducting devices? So that case, some hole or electron pair is happening in that electron transportation. In that case, some doping is due to that organisms or that particular particles. It changes some doping of electron or hole or charge carriers. So these are very important thing for the study of nanomaterials devices, especially this case in nanomaterial devices. So we should take care of that thing. uh, so lot of means impurities affecting the device fabrication. Similarly in the biological case also, as well as pharmaceutical case also, because we know everybody, the pharmaceutical industry made some medicines. These medicines is very um, uh, very important product, because medicine is directly related to human beings. So that medicine making, it should be in clean room. Otherwise a lot of contamination happening in that case. So it is not good for a human being. Now right now we know so much types of classroom, clean room. Different categories of clean room means lot of different categories available in clean room, like that. Class 1, class 10, class 100, class 1000, class 10,000, class 1 lakhs, like that class is available in clean room. So how we people say what class is uh, what number of class is denoted, how much the particle size in one volume per volume. This thing is denoted the particle size in that particular volume. So based on that we can classify the classroom category. So basically in clean room we actually we measure the 0.5 micron to 5 micron particle size only. Why we use 0.5 micron or 5 micron? Because the 0.5 micron particles is only the particle to participate some microorganisms or bacteria for traveling one side to another side. Other particles is not that much of participate to making contamination in the room. Therefore some us standard us federal standard and some ISO standard or WHO decided in the clean room only measure the 0.5 micron to 5 micron particle size. Other particle size we cannot measure in clean room. Based on that size, we decided the clean room category. So uh, these are the international standards for different countries like US, France, German, British, Japan, and ISO. The, I repeat my sound. Can you uh, close the speaker? Someone, hello.
Yeah, I see speaker is somehow open.
Okay, okay. So these are the some international standards. Every country have different kind of standard. They measure their own standard, the clean room category. But worldwide, mostly people use US federal standard or ISO standard. So uh, these are the images. For example, how categorize the actually clean room. So we can see in that images. So suppose, can you see my cursor? Yes.
Yes, yes.
Hello, can you listening my voice?
Yes, yes.
Yeah, sorry, some disturbance.
Yeah, no problem.
Yeah, so how to classify the clean room? Actually, these are the 1 cubic feet area. In that area, how much the particle size is available in that particular area. Based on that, we can classify the clean room category. Like here we can see the class 100 category, or class 100 category. This class 100, class 1000, class, this class thing is mostly US standard, US federal standard, and ISO is Indian, sorry, international standard organization. So class 100, class 100 clean room means ISO 5 clean room. So class 100 clean room means, in that clean room, suppose we consider one cubic meter area. In that area, 0.5 micrometer size particle available in 100 per cubic meter area. So in that particular area, 100 particles only, zero point 0.5 microns particle is available. So these types of clean room is called as class 100 clean room. Similarly, suppose we consider class 1000 clean room. In that clean room, that 1 cubic meter area have 1000 0.5 micron size particles. So uh, these types of classification we can made for a clean room. So what is the difference of this classification? Suppose some means, the vapor fabrication is very sensitive thing. So this thing is only did in class 100 category clean room. We cannot do in at means like open environment, because the silicon chip fabrication is very very sensitive to atmosphere. So for that case, only for that case the class 100 clean room is available. Otherwise, suppose we kept in some um, fabrication instruments or some production line is in 1000 category classroom. Only wafer fabrication is did in 100 uh, class 100 clean room. So
So, Vilas, in India, class 100 clean rooms are available in the market.
I for educational sector, I don't think class 100 is available, but India have a good pharmaceutical industries. So I think Ahmedabad have some class 100 clean room is there for pharmaceutical
Okay, okay,
purpose.
okay.
Yeah, for and we don't have semiconductor industry, so we don't have semiconductor class 100 clean room. But academic sector, never any institute have class 100 clean room. I think our TIFR is class 10,000.
Yeah, yeah.
TIFR clean room is. So these are the, actually previously I already told you some these are the some international standards. And there means some country like WHO measure the standard is grade A, grade B, grade C, like that. US standard is class 100, class 10,000, class 1 lakh. ISO is like that, ISO 5, ISO 7, 8. And these are the German standard. They also measure in grade class, grade 1, grade A, grade B, grade C, like that. So every country have different standard, but mostly all over world people use the US standard. Okay. So what is the important thing to make the clean room? So here I introduce some uh, means basic and important thing which we required for designing the clean room. So first one is uh, airlock, then air shower, garments, HEPA filters, pass box, and uh, ULAP filter, HVAC, then HU. These are the most important components for making the clean room. Suppose someone in future, someone is joining somewhere as a teacher, and he want to design the clean room. So maybe this thing is helpful for that purpose. So these are the more important things. So what is the airlock? Actually, airlock is the one kind of isolators. This isolator is maintain the environment outside of clean room and inside of clean room. Suppose someone is go inside the clean room, that time that airlock have like some interlocking doors. One door is opening, another door is always closed. After that, once you enter in that airlock chamber, so that another door is closed, then airlock chamber is vent, and then another inlet door of clean room is open. Like that thing is happening in airlock chamber. So airlock chamber have air shower. Actually, everybody goes in our TIFR clean room, I think. So when we wearing the cloths and enter the that air shower, so when we close the door and air shower is started, so what happened in that case, that air shower have some high velocity air, and this high velocity airs remove the contamination over the surfaces, means our garment clean room garment surfaces. So now the clean room garments, the clean room garments is a very special types of garments. We cannot wear the woolen or some cotton garments inside the clean room, because cotton garments and woolen garments produce some contamination. So therefore clean room environment not allowed to wearing some different kind of garment. So clean room garments is very special kind of garment which are made by synthetic fibers, nylon or dacron, or some plastic, means plastic types of garments is also available for clean room purpose. Then next component is the HEPA filter. Everybody know the HEPA filter. HEPA filter is the very very good component actually. This component is invented in after World War II. Before that, world facing the problem of making clean environment for making some good quality military products or semiconducting devices. So after Second World War, people develop HEPA filter. HEPA filters mean high efficiency particulate air filter. So in that filter, what happened, this filter is filtering the air, air, and in that filter the blocks more greater than 0.5 micron particle size, and pass only the less than 0.5 micron size particle inside the clean room. So the efficiency of that HEPA filter is near about 99.97%, means it's really good kind of filter. So most of lab clean lab have uh, s- uh, use HEPA filter. Then passwalk, some passwalk is the similar kind of concept like airlock. Only the difference is the passwalks have very small area. In that passwalk we can put our samples. Suppose we go inside the clean room, so we put the sample in that passwalk area, and we wearing the clean room cloth and go inside the clean room and remove our sample from that pass box. So Pass box is one kind of air locking types of system. And then sticky mat, everybody knows the sticky mat. Sticky mat is used for stick the particles over our clean room shoes, clean room shoe sole. So sticky mat seated in outside the clean room as well as inside the clean room. And then another one filter is ULAP filter. This filter is very actually costly filter and very accuracy filters, because the filter efficiency is 99.999%. So this filter is used only class 1 or class 100 clean room. So this filter because this filter is very high uh, highly design, and the cost is also very high. So most of clean room not required this filter. Means suppose we want to design class 1000, class 10,000, or class 1 lakh clean room, so we don't need to use this filter. But for information we can remember in this thing. And another one is more important component, HVAC means heating, ventilation, and air conditioning. In that unit, AHU is also working in that system. So in that system, what happened? We can see the image of HAV system. So this system is more important, because this system is only produce the clean room environment. So here we can see in that image, uh, uh, these are the HA, H, HAAC system, HVAC system. So HVAC system have lot of components like coil, cooling coil, humidifier, some walls. So what happened? Suppose some weather law is also, so weather law is one kind of uh, you need to protect some weather contamination. And purifier is purify the outside air, purify here, and then passes it heating coil heats the here, and some uh, uh, that particles blocking here by heating. After that, some particle passes in cooling coil also blocks some particles. Then it passes into the humidifiers. So humidifier work is, uh, suppose uh, we want to control the humidity inside the clean room. So humidifier, as per requirement, humidifier passes the air, and finally this air is goes to control damper. And through that control damper, the terminal filter, it's mean HEPA filter. Through this HEPA filter, the air pass in the clean room. So these types of working actually happening in the clean room. And that suppose some contamination in available in clean room, this contamination removed through this way. And some contamination directly uh, out to environment, or some contamination, some cases it filter again. Means suppose some inside the clean room we cannot use some hazardous chemicals, or some means no one is available in clean room. That time, that clean room air is filtering again through that HVAC system, and pass into the clean room again. But suppose some we use some hazardous chemical or contaminated chemical vapors, that case we pass this clean room air to directly in the atmosphere. So like that, bidirectional flow use in clean room mostly. So I already explained what is the weather Lorentz, silencer, flow rate controller, flow damper, heating unit, cooling unit. Everybody knows, I think, these things. Uh, so I will not go through much more details. So after that, next thing is the airflow. So airflow is the more important thing in clean room. So basically, three types of airflow available in clean room, like turbulence airflow, laminar airflow, and combined airflow. So turbulence airflow is the we can see in that image. Uh, in turbulence airflow, the airflow don't have any spatial direction, means velocity and vector relation is not available in turbulence flow case. So turbulent flow case is that air is circulating some kind like that. We can see that arrow types of air circulate inside the clean room. So if we use the turbulence flow airflow in the clean room, so what happen in that case, we cannot remove the particle contamination from the clean room, because turbulence airflow trap the particle, that contaminated particle in the itself. So turbulence airflow case is making clean room environments takes some more time. So these types of turbulence airflow available in more than 1 lakh classroom 1 lakh class type of clean room. But generally means class 100, class 10,000 or class 1,000 clean room have laminar types of airflow. So what is the laminar types of airflow? Laminar types of airflow is the directional, unidirectional airflow. Sometimes people use horizontal types of airflow, or sometimes people use vertical types of airflow. So in that case, what happened? The air is passing through the HEPA filter is very high speed in one direction. So due to that, what happened? The particle contamination is uh, means removed very fastly from the clean room. So most of clean room have that types of airflow is available. So uh, these are the actually block diagram. From that block diagram we can understand what types of airflow is helpful for making clean room. So here these are AHU is mean this is the one of the component of HVAC system. So HU is a air handling unit. So air handling unit have like that humidity, temperature, and pressure inside the clean room. So that uh, outside air is passed through that AHU unit, and then it goes to like that. Suppose this image first is turbulent flow. So this turbulent flow is different kind of turbulent flow. So what happened when we pass the air from HEPA filter, that main filter it's mean HEPA filter. So the air goes to little down, and then it's come out through that ventilation uh, units of the clean room. Second one is second image is unidirectional, means laminar flow units. So here we can use a lot of vapor filters in a clean room uh, uh, clean room top of the surface. So through that HEPA filter we can pass the air only one direction, very high speed, and then this air is come out through the ground, and it goes through that ventilations line. And third one is again this one is turbulent flow, but this one is different. For this making these types of turbulent flow, we use some dispenser unit below the uh, below this main filter. So what happened due to that dispenser unit, it's create some different kind of turbulence flow. So these types of turbulent flow we use dilute the contamination in clean room. Means suppose this is the clean room, and some one of the area have a lot of contamination, and other area don't have that much of contamination. So through this air system we can dilute the one area contamination in over the clean room, and after that we pass the unidirectional flow and we clean it at the clean room. So combined airflow have both types of airflow used in that clean room, like turbulence as well as laminar flow. So these are the clean room facility which I was designed during my PhD at my university, North Maharashtra University. So when we making the clean room that time, we study a lot of things. So in that photograph we can see this is the clean room which we designed. So here we can see that the top of this clean room units have some HEPA filters. This one you can see in my arrow. This thing is the HEPA filters. And making clean room is that clean room walls is also different kind of materials. Like that sometime we use aluminum powder coated wall, or sometime we can use aluminum uh, or epoxy painting wall. And epoxy painting wall, so similar kind of material we can use some plastic, different kind of plastic materials also used for the making wall of clean room. And one more thing is, when we decided to making the clean room, so we should count the things like how many gas line we need inside the clean room, how much outlets of the gas like vacuum pumps and another things, we should count it. And even power supply is also important things, because we fit lot of instrument inside the clean room. So as per that we can make a list of uh, instrument, and what kind of power supply is needed for that instrument. We should make the list as per our requirement. And as per that we can made the connection inside the clean room, because once you made the clean room you cannot uh, make the electrical connection, because it's take very hectic thing. It's making some contamination also when you cut it the clean room wall. And making some changes is not that much of good thing for the established clean room. So before that we should count everything to made the clean room, before made the clean room. So uh, these are the photographs which this clean room is available in my university, North Maharashtra University. Next. So these are the things which is more important actually for the clean room, operating the clean room environment. So what thing we do and what thing we cannot do inside the clean room. So these are the basic thing actually. So when you go inside the clean room, you should take care of your cloths, less motion in do the less motion inside the clean room. Like if you even you move inside the clean room, you can produce some particles, and these particles it's helpful to making the contamination of your device fabrication. So when you do inside the clean room, you should use very less movement, as well as uh, you can use like hazardous chemical, mostly avoided the hazardous chemical. And some vaporized chemical also you should avoid inside the clean room, because this things is actually not good for clean room, because it's produce some contamination. And even inside the clean room, like that pencil is not allowed it, some wooden types of thing is not allowed it inside clean room, erasers, like that food, cold drinks, some like that cosmetic. Even some ladies is go inside clean room, so sometimes they will do some cosmetic things, jewelry. These things is also not allowed it, inside the clean room. So we should take care of that all things before entering the clean room. And this is our responsibility to maintain the clean room environment. uh, we take next. So this is the last slide. So from that presentation, I'll conclude the actually clean room, maintaining the clean room or making clean room is itself very difficult task. You know, the every time measure the particle contamination, and that HVAC system, every day you look it's working or not. So it's really hectic and difficult thing to make the clean room environment. Another one is the how much the impact uh, is make contamination in your device fabrication case or product production case. So you should take care of that thing. Then designing of clean room is also the very tough task. So suppose in future you people wants to do you people have some opportunity, definitely you can do the you can do the clean room designing, or someone you can helps the tips of how to making the clean room. And so a lot of things we can learn from this presentation. So thank you.
Thank you, Vilas, for the
Any
nice presentation. One quick question. So let's say there is a sudden
yeah,
unwanted gas
just
leakage.
1 minute.
Yeah, sure.
सुभोजित याला घे ग तिकडे बाजूला. बाहेर घे ना, तुला सांगितलं ना. ठीक आहे. हा, कंटिन्यू सुभोजित.
Yeah, I was asking that if there is some unwanted gas leakage or something inside the clean room, so how to purify the air?
Actually, I already described na that HVAC system have that facility actually.
It can
So if
purify any type of impurity.
yeah, because I will show you. In that image, you can see, suppose some hazardous gas leak inside the clean room. So this gas is passed through this way. This filter is filtrate something here. So this filter is blocked some hazardous thing, then pass into the fan. This fan is help to remove the hazardous gas from that filter. And then this one is a flow rate controller. So suppose the hazardous gas is lot of amount of hazardous gas, this flow rate control this gas flow. And this silencer is one kind of like some air, due to air pressure, some volume is occurring. So silencer is reduce that volume and dilute the that hazardous gas intensity. Means suppose the gas is more hazardous, so in that silencer we put the gas in some particular like water or some chemicals, in which chemicals this gas is put passes through that chemical and it's diluted, and after that this gas is put in environment. Like that way we can reduce the contamination gas from the clean room or hazardous gas from
Okay,
the
then like after a certain amount of time, the filters need to be replaced itself because they will absorb.
Yes, of course, sure.
Okay.
Certain of time, this is the essential thing actually.
Yeah, so how to
Therefore,
understand the health of a filter? Like, is there easy way?
actually the in the maintenance of clean room, every means suppose you is actually maintenance is depends on what category of clean room is available in your institute. Based on that maintenance is depends. Suppose your clean room is 10,000, so every 6 months you should check the filters of that airflow system. So every 6 months you should check, means your system is working properly or not.
Means if it is not working, then the clean room particulate count will go up. That's the way to check, right?
Yes, right.
Okay.
Vilas, one related question. So in clean room, we for RI system or some other system, we use some gases like CHF3. So after they are used, they are taken out by the pumps, right? And then
Right,
do
right.
they directly expose to environment, or they, I think,
No,
as
no,
you
I,
mentioned here, they are processed.
no, no, no.
They are being
They will collect the outlet gas, and you know that outside the clean room some bigger chamber is there. I don't think you people remember or not. But when you push the door lock button, na, that near that door lock button
yeah,
have
yeah.
one is the chamber like that,
Right, right.
circular thing. Yeah, this is the actually silencer thing. So this gas is passed through that silencer thing, and that silencer have
Okay.
dilute that gas, and after that dilution the gas is passed at a environment. Means that diluted gas is not that much of hazardous as compared to pure gas.
Okay, okay. So if one day you can show the component based on this
Sure,
diagram in the
definitely.
clean room, that would
Actually,
be helpful.
we people know the HVAC system. When we wearing the cloth, na, that side
Hmm.
of that bigger units is HVAC systems actually.
Okay, I thought that was AHU. Anyway, okay.
Yeah,
Thank you.
means that washing machine is there, na. That
Mhm.
side is HAAC system, HVAC system is there actually. And upside that duct is suppose you see the top of the clean room, you saw some duct lines.
Yeah, okay.
Yeah, so that duct lines, below that duct line, the HEPA filter is mounted actually. I will show you. When I was come there, I will show
Yeah,
you
okay, okay.
the
Yeah.
things. Yeah.
Any other questions? Any other questions from the audience? Okay, if not, then let's thank Vilas ji for this very nice